Good morning, India. Good evening, US. This is the team GreenWeaver. So, to start with the introduction or the problem statement, the major area on which we have focused is the making of the screw-fine mats, which almost most of the people in India, especially in Kerala, use this mats in their homes. So the major problem that we found out during our research and our trip was these industries are facing a lack of labor shortage because of the weaving process, which is very tedium and because it causes very stress and back pain, very health problems to them. The KRDA, that is the Kerala Rural Development Agency, which is the non-organization NGO, which has suggested us to make some product so that the weaving process that the artisans they are using can become easier. So the mission statement of our group is the design and produce a cheap and user-friendly weaving machine to improve and expedite production of screw-fine mats and other handicrafts. Next is the market research. As I have said earlier, the screw-fine business is diminishing day by day because today's generation is not ready to work in this industry because of the problems that the artisans are facing. So it may die out. It is said that it may die out in 5 years. And the end users for our product is the female artisans. Mainly we have focused the artisans in Karnagapalli. And also the main customer is the KRDA, and if we extend this production, they will become our distribution channel. Earlier attempts also was done by KRDA and other organization but that was failed because of the constant breaking of strands because of the stress on them. And the demand is very high for this screw-fine mats, but the supply is very low because, as the statistics said, that KRDA alone has the demand of almost 600 mats per year, and also there are almost 7,000 plus families who need this device, who uses this screw-fine mats. So the demand for our product is very high.
Okay. We do have market and product specs available during the question and answer period. We didn't display them in the main presentation, but for those of you who are curious, we have specs and cost analysis. As far as our design progression, just a brief roadmap. We had an initial prototype here, which is similar to a loom. We upgraded to a diagonal frame with rails, after which we got feedback from customers. Then this term we went to a half-scale prototype, which we manufactured with Mr. Biju in Kottayam. We received feedback on this actually yesterday, and we are moving forward with a new lifting mechanism. So with our initial prototype design, what we wanted was to have alternate strands being lifted up for leaves so that we could have interlocking. So we have offset gaps between these two holders, and one of the holders can be lifted up or down. Depending on whether it's up or down, we can interlock one way or the other. So this solved the problem of interlocking, but the problem with this is it still caused a lot of stress to be placed on both ends of the strands, and it didn't encourage the diagonal weaving process that the artisans would have liked to use because that's the process that they've used for any number of years. So by the end of term one, we upgraded to a prototype, which is shown here. We added rails to the side with a frame between the rails. And you can see this device right here, which is a cylindrical piece with pins and a slide rule. The slide rule is at a 45-degree angle to the rails. So when we rotate the cylinder, the pins will push up half of the strands, through which we can do interlocking. Then if we slide this rule by one strand width over, because of the 45-degree angle, in the next iteration we would lift up the other set of strands. So what was nice about this is that people could sit to operate it and maintain the diagonal weaving process. We obtained qualitative feedback on this, but not quantitative feedback, because it was really a proof of concept more than anything. KRDA liked the initial idea and encouraged standardizing the mat strand dimensions, which this device would have forced, because since we're moving over multiple iterations, the strands would all have to be the same dimension to avoid an error rate. We were able to talk to 6 artisans who had the positive feedback we couldn't diagnose. And Vinay also told us that this idea worked because it avoided placing stress on both ends of the strands, which is a problem with the conventional loom.
And now, based on the feedback that we received, we managed to have rough designs and having approximate dimensions, we were able to make up a half-scale prototype with the help of a local carpenter, Biju. And for this prototype, we mainly have a strand holding mechanism, strand lifting mechanism, strand guiding mechanism, and a firm leg support. This for this prototype, dimensions was appropriate, and it was taken in such a way that we can weave out a 1/3 of a full sleeping mat from this device. And the cost of manufacture for this device was around 4,970 rupees, which is approximately $90. So on the next slide, we can see some design issues with this prototype. For this one, the horizontal strands which were laid perpendicular to the initial strands was not held tight. So there was a possibility of gaps having in between each strands, and the parallel strands which lay close to each other interfere with each other and cause difficulties in lifting up of alternate set of strands. And the working of this prototype can be seen by a small video. We can move the video.
One second, Majesh.
Yeah.
Oh, mine. There we go. All right, go ahead.
Okay. This shows our prototype, and the strands are initially placed in the slots in the strand holding mechanism, and the mechanism can be moved on the rails. It can slide on the rails, and by initially properly placing these strands, we can lift up the lifting mechanism and make folding in it, and we can insert the perpendicular strand in between. And by moving a distance of perpendicular strands backward, the the other set of strands get on top of the lifting mechanism, and we can lift the next set of strands. We can insert the next perpendicular strands.
There you can see the problem of lack of tautness, strands interfering with each other. And here as well, you can see a problem of this holding mechanism, the L-shaped scale, being hit by the fingers and moving itself. Okay.
That's the webmail. You want to find the full document.
There it is. But go ahead, Mathews. Oh, sorry. Mathews, you're muted. Start over. You're muted.
Hi, this is the feedback of our half-scale prototype and the new lifting mechanism. So they are actually happy with our current prototype, and we got feedback from Mr. Salim, 15 female artisans, and the officials of KRE. So they are really happy with our current prototype. They said that the holding mechanism, the L-shaped member, that actually helped them to weave in the conventional way or the traditional way of weaving. That's a good advantage of our mechanism. And they like the frame because it is very strong. And they like the fingers. They actually help them to weave the alternate strands. And there is some problem with the rails. If we increase the size of this prototype, the space of the rails consumed by the rails is very high. So we are looking for a folding rail, and they are preferring for the tight weaving of the strands, and the shifting of the holding mechanism may cause by the movement of the fingers, finger-like mechanism, and the other we made some average points and a score sheet based on our feedback. This is a score sheet. With the help of us, where they are able to identify or understand how to operate this device. The score is 7.5, and the efficiency of comparison of the efficiency of our prototype with the manual weaving. We put 5 for the manual weaving, and we get only 2 because this is not fully functional. And about the cost of this prototype, how affordable will the device be a full scale, that is the cost will around 7,000 rupees. So we got a score of 9, and comparison with the current technique is it's our design give a better comfort, but it is not fully functional right now, so that's the problem. And the additional concern that we have is the portability of this device and the space consumption, because the space available in the laborers or workers' house is very much less, so that's the problem. And the ergonomics, we are just using the hands only for the working of this prototype, but we are looking for the use of legs too. So the additional features that is needed for the artisans are the adjustable height, so that they can avoid the shoulder pain, and the strand straightening mechanism. Currently they are using a knife to straighten the strands. If you can attach a straightening mechanism here, that's better. And the strand holding basket mechanism, because presently they need to take the strands by bend down, so that also makes some problem. So we can solve that problem by attaching a strand holding basket. But about the manufacturing, Sahin suggested multiple carpets in that area, and he said he can arrange some more contracts with the machines, and he suggested they will wait for our final design, and they will work with us.
Okay, so based off this feedback, we're working on a new lifting mechanism. So the parts of this that matter are basically we're making it one piece. Instead of a lifting mechanism and a guide, we're making just one piece to perform both functions. And instead of multiple fingers, which is a lot of parts and costs a lot of money, we're trying to lower that cost by making just one piece. This also won't interfere with that L-shaped holding member. So we're hoping that that'll solve that particular problem. And the way that we want this mechanism to work is we're going to push the mechanism towards the point of interlocking, at which point half of the strands will have a 90-degree angle to the others, and then we'll just pull it away while placing horizontal strand down to achieve interlocking.
One of the issues we face is traveling, because the artisans were focusing on using Karangopoli, which is pretty far away from the school. So we couldn't be able to talk to them as much as we could. And we think if the distance is shorter, maybe we can discuss the prototype with them more, and thus moving the project forward faster. We have a couple of design issues that we have to fix before moving the project forward. One, as mentioned before, is making sure the interlocking is tight, as well as making the prototype usable for strands with different width. And lastly, the strands are easy to get tangled at the end, so we want to make sure we fix the prototype according to that. And while we're fixing the design issues, we want to keep manufacturing in mind, such that we want to reduce the number of pieces total to reduce the total cost as well. For plan beyond this class, we would like to continue this, and other than focusing on the design, we would like to maintain good relationship with manufacturers and showing them engineer drawings, taking feedback from them. And after we're pretty comfortable with our product, pretty confident about our prototype, we would like to measure productivities. And our goal is really deliver this prototype to artisans so they can benefit from it. So we would like to set up really good maintenance system and make them use this prototype as soon as possible. We're also thinking about fundraising from the NGO KRDA and from Caltech and St. Kitts. and also from TCP program, which suggested by Celine that we can apply and potentially get funding. For the lessons learned, the first one is quantitative feedback is very useful to help us make design decisions. For example, what's the price range they are willing to pay, how comfortable they are operating this device on scale from 0 to 10. The second thing we learned is schedule did not work as planned. We initially planned to visit the customer at least twice this term, but it ended up only once that we went yesterday. But it was very useful to get feedback from them. And lastly, communication between the US and India could be difficult because our prototype have very complicated mechanisms. So explaining the ideas from US to India and other way around could be difficult with just conversation. So we think we can aid that with videos.
So lastly, we just wanted to have some acknowledgements. All the professors here, Katya, this is probably the most difficult student job you could take at Caltech.
I would disagree with that.
You're wrong,
Our
then.
engineer, Jang, KRDA, Mr. Biju who made our prototype, and of course the artisans who we work for. So,
Right. Questions? I must say that video, that was the first time I understood what the structure was. Maybe
It only
it's
took
me.
2 terms, right?
Yeah, maybe it's me, but that showed it very clearly.
Katya.
I was wondering, you talked a little bit about your plan to move it forward, but which of you are actually going to be able to work on it after you?
So, both, I think Majesh and Mathews are going to be working on this for the foreseeable future, at least for the next couple of months. Judy and I are going to stay at least until we can get a working prototype. And I'm thinking about possibly going to India in the summertime. That's still kind of in its infancy stage though.
Sounds good.
Okay. All right, thank you.